Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Hakimi bin Azman from AC1104D. I am the first presenter, and our group will cover the topic computer integrated manufacturing. Prepare for Madam Azlinda Muhammad. So first, let's look for definition of CIM. CIM, or computer integrated manufacturing, are integration of computers into manufacturing system. CIM is not the name of a product that can be purchased directly. CIM is defined as a method or technique that includes all computer applications to control the entire manufacturing process, ranging from design, analysis, planning, purchasing, inventory control, material handling, and others. CIM is one of the implementation of ICT in manufacturing. So here we can see illustration from development, production, packaging, and lastly delivery to the customer. History of CRM. Who introduced it? It was introduced by Dr. Joseph Hannington. He is the first to fully define CRM. His book, Computer Integrated Manufacturing, was published in 1974. He is out he is automation expert and a major contributor to the technology of numerical control. His theories lead to computer managed operation. He also received many awards. Timeline: what happened to CIM in the 1980s? CIM began with automation of product operations. The term computer integrated manufacturing introduced in 1974. Until 1984, it was ignored. Throughout 80, CIM developed and promoted by the Society of Manufacturing Engineers, or SME, Computer and Automated System Association, or CASA, and various manufacturers of machine tools. Okay, CIM characteristic. There are three characteristic. CRM covers the use of computer software package in the entire product development process and manufacturing process with all activities. The data needed for this activity is seamlessly passed from one application to another. And the lastly is ranging from product needs data from marketing, specification data from the design division, production process planning data, to delivery of goods to customer and their feedbacks. Objectives of CIM. Objectives of CIM, there are 7 objectives. The first, lower cost of production, including both direct and indirect labor. Second, optimize inventory levels, lower downtime, improve scheduling flexibility, maximize efficiency, identify loopholes that obstruct production and hit the company bottom line. And the last one is assist management in collecting relevant data to optimize efficiency. Implementation of CRM. There are 10 stages of implementation of CRM. The first one is computer aided design, or CAD. Stage 2 is prototype manufacture. Stage 3, cost and production methods calculated. Stage 4, materials automatically ordered. Stage 5, manufacturing begins using CAM. Stage 6, quality control applied at every stage. If fail stage 6, it must be manufactured at stage 5. If quality control successful, it will go to stage 6. Stage 7, product assembled by robots. It's the same as the stage 6. If the quality control fail, repeat at stage 7. And if quality control successful, going to stage 9. Stage 9 is product distribution to the customer. And the last one, stage 10. Financial account are updated. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad HAFIZUDDIN bin Ahmad SABRI from class AC 110-4D. As a second presenter, I will present about advantage and the advantages of CIM, Computer Integrated Manufacturing. Okay, first we will talk about advantages. We have four advantages here: error reduction, speed, flexibility, and integration. First is error reduction. CIM systems require higher degrees of data accuracy to run properly. Once part, bill of material, inventory, and operational information achieve a very high level of accuracy. CIM can perform functions with minimal human intervention and then report on the results automatically. Humans are still required to monitor systems, but elimination of human error in many assignment and reporting functions on factory floor operation drastically reduce the error rate. Next is speed. Assignment and reporting in a assignment environment in a CIM environment are performed automatically and immediately without any delay involved with people-based transaction. Depending on the environment, this additional speed allows operation to be performed as soon as previous work occur without any lag time. CIM environments therefore reduce the time it takes to perform manufacturing, fabrication, and assembly, allowing quicker flow of product to customers and increased capacity. Next is flexibility. Once operations are assigned and reported in a CIM system, changes to various operations can also be performed more easily. CIM systems are designed to be entirely paperless, eliminating the barriers to changing operation. This flexibility combined with the speed it can be performed allow companies to quickly react to market conditions and then return to previous settings when market conditions change. Last is integration. Factory floor operations are not integrated in non-CIM situations. Manufacturing operation and material usage must be reported by humans who perform transactions. CIM offers a degree of integration that enables the flexibility, speed, and error reduction required to complete and lead markets. Integrating factory floor operation with enterprise software enable employees to do higher value functions for their companies. Okay, next is disadvantages. We have four disadvantages: cost, maintenance, training, and quality. First is cost. Computer technology used in CIM is expensive to implement and support. This is complicated by the fact that technology is not constant. New hardware, device, and software programs constantly come on the market, and engineers and business people must try to keep up with this change for compatibility reasons. Furthermore, it costs money to train staff members to use the technology. This means that the cost of CIM does not stop after the initial implementation. Next is maintenance. A broken machine and to repair it will incur a very expensive cost since spare parts for the machine are very expensive and hard to come to come by. This makes repair costs very expensive. A faulty machine is also difficult to repair because it requires someone who is knowledge and expert about CIM because the system is very complex and only skilled people can repair it. The system also takes a long time to repair due to its relatively complex system and expensive and difficult to find spare part components. Next is trainings. Employees in this division need to have high skills. Therefore, employees need to have initial training on the CIM because the system is very complex and is an expensive component and needs to be operated by a professional person. It is necessary to have initial training so that workers can do the work easily and comfortably to do work with this complex system. Lastly is quality. Because CAM system works with the same blueprint every time, they can be highly accurate in terms of producing the same quality of product. However, glitch can do occur. Since the manufacturing process is automated, company workers may not discover the flaw unless they have a good quality. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAFIZ HAMZI bin Muhammad TARMIZI. Now, I will present to you about the computer integrated manufacturing. Or more specific, for my topic, I will explain about the subsystem and how the subsystem work in the computer integrated manufacturing and conclusion for our topic. So let's go and see. System in computer integrated manufacturing. There are so many types of subsystem, and today I will explain to you all of it. So first we have computer aided design, or short form is CAD, where involve the users of computer to create the design drawing and product model. So this is very important in the manufacturing to create a drawing and product model. Second one, we had the computer aid engineering, is the broad usage of computer software to aid in the engineering tasks. Third one, we had the software at manufacturing, where it use the use of computer software to control the machine and relate machinery in manufacturing of workpiece. So this subsystem are used to make the control of machine tool and relate machinery. It's very important for the manufacturing also. And next we have the computer aid process planning, where is use of computer technology to aid in the process planning of a part or product in manufacturing. So with this subsystem, CAPP, computer aid process planning, they are used to process the planning and product for the manufacturing. So that is very useful subsystem in the CIM. We have computer aid quality assurance, or CAQ, where is the engineering application of computer and computer control for the inspection of quality of product. So this subsystem are useful to inspect the quality of product. So that's very useful. And next we had the production planning and control, PPC. A production planning and control system is concerned with planning and controlling all aspects of manufacturing. all aspects of manufacturing, including material, scheduling machine, people, and coordinating supplier and customer. So this production planning and control very useful to the manufacturer. So next, enterprise resources planning, ERP. The system is integrate internal and external management information across an entire organization, embracing finance, accounting, manufacturing, sales, and service. That's how the subsystem in the computer integrated manufacturer works. We already hear about the subsystem in the computer integrated manufacturer, right? So there are also subsystem that used in computer integration where it device and equipment required. Device and equipment required in the computer integrated manufacturing. So what is the device and equipment required? So first we have CNC, computer numerical control machine tool, DNC, direct numerical control machine tool, PLCS, programmable logic controllers, robotic, computer, software, controller, networking, and interfacing. So these all device and equipment required also in the computer integrated manufacturing. So that's all the subsystem that um, are in the computer integrated manufacturing. So now let's go see how the subsystem work in the computer integrated manufacturing. So let's go. If you can see the slide above, we can see the schematic diagram of CIM, where the CIM also work with subsystem. So we can see first the design, request of engineering action, then go for the engineering development. So for the engineering development, we use CAD, computer aid design, where we use to drawing and what we call drawing the model, the product, and go to the production definition, go to the engineering release, and go to the manufacturing definition, go to the manufacturing process, go for the business and production planning, go to the plant operation, and lastly the finished product. So these are the schematic diagram of the CIM show that the subsystem also used in the CIM to make this what we call schematic diagram perfect, smooth, going smooth until the product finish. So without the subsystem, GCIM, integrated manufacturing, cannot live by its own. So with the subsystem like and device and equipment also required for the CIM, software, uh, robotic, computer. So that's very used in this computer integrated manufacture. So that's for the that's how the CIM work with the subsystem. So now we have finished our computer integrated manufacturing. So what we can conclude from this topic, the computer integrated manufacturing is a manufacturing approach of using computer to control the entire production process. Like we can see the example, right? how the computer are used from the development of engineering, CAD, computer aided design, until for the finished product they use the computer. And this integration allow the individual process to exchange the information with each other and initiate action. You can see from each other, integrate, allow the exchange information, right? And through the integration of computer, manufacturing can be faster and less error prone. Although the main advantage is the ability to create the automated manufacturing process. So this computer integrated manufacturing, if we use, it can be faster and less error prone. So that's all from us. Thank you.